So my name is Mark Hill. I'm a professor at the University of Wisconsin, and I'm soon going to be vice chair of the CCC, the sponsoring organization for this conference. It's my distinct privilege to introduce Ed Lazowska, who I've known for many decades. He's the Bill and Melinda Gates Chair at the UW, the other UW, and he was the founder of the CCC. His accomplishments are very long, and I wouldn't give him any time to talk if I went over them. But among them is his great book on quantitative system performance, which was very important to my career and actually my consulting, including Little's Law. And the gentleman that had trouble estimating the ambulances latency should talk to me, because Little's Law works there as well. Ed also has tremendous accomplishments in parallel and distributed systems, scheduler activations, lightweight remote procedure call. And if that wasn't enough for a great career and to get him into the National Academy of Engineering, his service has been equally great to CRA, NSF SIZE, DARPA ISAT, and as I mentioned, the founding chair of the CCC, which he then ran for 6 years. So I think Ed's real title should be Catalyst in Chief. And he's going to talk to us today on computer science, the ever-expanding sphere.
Well, thanks, Mark. We were having a discussion at lunch that he's from Wisconsin, which is the next Riviera if we just hang on a few years. Waterfront property, orange trees in the backyard. It's going to be great. It's a real pleasure to be here. It's an honor to be here. I'm just going to speak to you for 15 minutes, and this is going to be a sort of general rah-rah about things that many of you already embrace, and I'm going to try to do it without slides, but just in case, there are some slides in the middle of each of your table that will provide some background information, so you might pick up one of those. Before I start, I wanted to do two things stimulated by this morning's discussion. One is to inject a bit of data into Carter Hughley's comment about housing prices in Austin, Texas versus Seattle. And I think data is important. And this is, first of all, not to assert that we don't have an affordability issue in Seattle. We have a serious affordability issue we have to address. And it's also not to encourage people to move there, except for my many friends in these rooms. You're welcome to join us. But there was a very interesting study published last November that looked at several dozen different municipal areas, including Seattle and Austin, Texas, Boston, San Francisco. And what it did for each precinct in these cities was to classify housing relative to the median income in that area as affordable, mixed, or high-end, where there's a lot of sociological data that says the more mixed housing you have, the more vibrant your community is. And interestingly, Seattle ranked second among all those metropolitan areas in economic integration in housing. Okay, pretty interesting. Seattle was 31% mixed and 59% affordable. Boston was slightly more mixed. That's the sort of criterion on which they ranked them. Interestingly, San Francisco was 2% affordable, right? And Austin, Texas was only 16% mixed, so is more economically segregated than Seattle. So it's very interesting to think about digging into the data in these cities. And that's the second point I wanted to make about this morning's many excellent presentations. It's that I didn't realize this was a conference about data science. That's very interesting because it was sort of big data, big data, big data. And it's a chance to talk about the role of the Computing Community Consortium, which so many of us have worked so hard on over so many years. You'll hear later today from, maybe tomorrow, from Tom Khalil from OSTP. And Tom has been the guardian angel of computer science really since the Clinton administration, with a brief 8 years off in the middle. Tom, by the way, always reminds us that having Tom Khalil in Washington, D.C. is not a good long-term strategy for the computing research community. He's not going to be there forever, but he's been extraordinary for us. And in 2010, Tom was trying to launch the Federal Big Data Initiative and get multiple agencies on board, and asked the Computing Community Consortium to produce a set of white papers on data science. And these were targeted at specific federal agencies. So you have to think of them as roughly saying, Mr. or Ms. Agency head, here's the direction that your agency is headed, here's your charter. here's how the use of large-scale data analytics could help you fulfill your mission more effectively. And we had papers on the smart grid, healthcare, transportation and urban design, personalized education, new biology, national security, advancing scientific discovery. And Tom has given us excess credit for helping to get agencies, multiple agencies beyond the obvious NSF, on board in the Federal Big Data Initiative. So I think that's, that goes back 6 years, but I think CCC has played a really important role in that and other activities, so it's great to see. So I titled these remarks, Computer Science, the Ever-Expanding Sphere, and that's a phrase I borrowed from Alfred Spector, now retired from Google. And it's a statement about two different things. One about the sort of growing role of the field, and it's also an exhortation to embrace this growing role as part of what we do rather than as something we do for somebody else, right? So this is going to be done in partnership with other people, but really my pitch is that we embrace this as part of computer science. So again, you have a handout, 8 slides in teeny font, and let me just sort of sketch the argument. There's a wonderful book called Turing's Cathedral by George Dyson. Has anyone here read it? A number of you. I really recommend this. It's a story, it's sort of the social history of the Institute for Advanced Studies in the 1940s and 1950s when von Neumann was directing the construction of the Institute for Advanced Study machine. And one of the things it points out is that von Neumann had application groups in a set of areas, numerical weather prediction, thermonuclear weapons, of course, Monte Carlo simulation, genetics, right? All of these were application motivations for the computing work that the folks at the Institute for Advanced Studies were doing. And honestly, as our field advanced, I think we've had a tendency for 50 years to focus inwards we had a phenomenal 50 years of making things smaller and faster and less expensive, and advances at the core of the field are going to continue to be of tremendous importance, and you can see them all around you. My friends in programming languages, for example, have done just astonishing things in very recent years. So these are vibrant and critical areas, but honestly, except for we in this room who care deeply about compilers and operating systems and computer architecture, most people care about sustainability, the health of our cities, education, improving the outcomes and reducing the cost of healthcare, security and privacy, the future of work. These are issues that affect society in a really significant way. And fortunately for us, each of these societal challenges is tightly coupled to advances in the core of the field by a set of what I'll call maybe more outward-looking or newer areas such as visualization, which our field has taken particularly seriously in the past 10 years or so, machine learning, robotics, human-computer interactions, sensors, computer vision, speech and natural language processing. So advances at the core of our field are tightly coupled to all of these societal challenges. And what I want to do is encourage all of us, again, to embrace these as part of what we do, although we do them, of course, in partnership with others. And my motivation for this, and a number of you have heard me say this before, is an article from 1998 by Bob Luckey when he was running Bellcore, Bell Communications Research. And this wasn't the title of the article, but the money phrase was the last electrical engineer. Okay, so this was in IEEE Spectrum, and the cartoon that accompanied the article was a little inverted pyramid, okay? And on top of the pyramid were a bunch of little people sitting at workstations, interestingly enough, and underneath was one little cartoon character holding it up. And what Bob was saying in the article is, if we as electrical engineers fail to embrace all of the things that our technology enables, then eventually there's only going to be one of us. And that person is going to be really well compensated, but that's not enough to maintain the health of the field. Right? And instead of taking this as a ding on electrical engineering, I took this as a cautionary tale for those of us in computer science. And I remember my department 20 years ago, honestly, having a very difficult time, and in fact failing to embrace a faculty member whose research was resulting in publications in a medical field, as opposed to in traditional computer science journals and conferences. Okay? We didn't get it back then. So I think we really need to embrace all of this and recognize that it's what's driving the explosive growth in computer science. There are many factors driving that growth. The Bureau of Labor Statistics, for example, if you interpret the statistics with a bit of a biased eye, says that 73% of all newly created jobs in this decade in all STEM fields will be in computer science. Okay? Engineering is 10%. Engineering is electrical, mechanical, civil, chemical, aeronautical, materials. And these are not just jobs in the computing industry. There's an ongoing study of the aerospace workforce in King County, Washington, where I live, the former home of Boeing, but Boeing is still big there. And interestingly, there are, depending on what you count, 4 to 5 times as many computing people employed in the aerospace industry in Washington State as there are aeronautical engineers. Right? And it is by far the biggest workforce pressure they feel in the next 5 years. So just astonishing. The workforce gap overall in computing in Washington State is 4 times as great as the number 2 field, and the number 2 field is all of engineering added together. So the role in the world, I think structural changes in the economy mean that the enrollment boom that we face is going to persist. And part of what we have to do is convince our university leaderships that this is the case and honestly that they have to grow the field. So first of all, of course, every 21st century citizen needs computational thinking, and God bless Hadi Partovi and Code.org for bringing now nearly 250 million kids into the hour of code. This is going to create tremendous pressure and opportunity going forward. Secondly, of course, every field is an information field. That means that people need more than just a first course, more than a familiarity in computational thinking. And third, as I've said, kind of all the STEM jobs are in computer science. So what we see academically is that these 3 factors are driving incredible growth in our introductory courses, incredible growth in upper division demand by non-majors, and incredible growth in the major. And I have 3 little charts in your handout. One is UW's introductory course, which is, like all of yours, growing like crazy. We taught 3,000 students in our first course last year. The second is a several-year-old chart from Berkeley showing the growth in upper division enrollment by non-majors, again through the roof. The third is majors enrollment at Harvard. Computer science has gone from the 20-something most popular major 6 years ago to the 3rd most popular major today. Right? So this sort of astonishing growth. What we've tried to do at the University of Washington is to make faculty investments not just in machine learning and computer vision, but in hiring new people and encouraging people on the faculty to really tackle in partnership with others these societal challenges. So for example, you hear later today from my colleague Zoran Popovic, who is 100% all in personalized education these days. And you'll get a feeling for Zoran for the sort of stuff we're trying to do, again, in partnership with others, but really tackling these societal challenges with computer science at the core. So I really think that we have the best 50 years ahead of us, as much as we've done in the last 50 years. And I think we're going to be judged by how advances in our field enable successful responses to these societal challenges. And that's what I think all of us as computer scientists need to embrace. This ever-expanding sphere means that computer science is a unit of the entire university and really fundamental to shaping the world that we want to live in the next 50 years. That's the message, and I hope we can have some discussion for the next few minutes. We've got some time left, so thank you very much. Questions or comments, and I'll repeat them if we've got some, so folks can hear. Yeah, please.
If I may, and in looking at the chart, the very first slide here, I was intrigued by the fact that you did not have the word food in there. And so something for you to consider as
Yes.
you give additional talks later on.
The comment is that that food belongs on the first chart, and I heard your talk this morning, and I subscribe to that fully, and I'm on it. Thank you very much. Again, it was a really compelling talk, and the fact that Minnesota is now the Corn Belt was just mind-boggling to me. And he pointed out to me that there are many other examples. For example, there are monasteries that have records of grape production going back more than a century in some cases, and you can see the migration of this. So there are many examples of the migration of crops northward as climate changes. Really interesting. Moshe.
If we are everything, what are we?
So that's a challenging question. If we are everything, what are we, right? Let me, as always, answer a slightly different question than the one you asked, which is a little too challenging. I've been involved in running the Data Science Institute at the University of Washington for the past half dozen years. And an interesting question for me is whether data science is more like computer science or computational science. Okay? And here's what I mean by this, and I'll now go out on a limb and probably get attacked. I think that computer science has a demonstrable center. People get degrees in computer science, you hire computer scientists. Computational science, I think, is something that everybody just does, and you don't hire a computational scientist, you hire a chemist or an astronomer who happens to do her work computationally. And I believe data science has that latter flavor. So we're not introducing a PhD program or a bachelor's program in data science. We're putting multi-course modules into all sorts of different fields. So personally, I believe that there is always a core of computer science, and I think that what we're trying to do in data science at UW is produce what my friend Alex Zale at Johns Hopkins calls pie-shaped people. That is, people who are highly capable both at advancing the methodology and in advancing some field, and creating this virtuous cycle in which advances in the methodology create new discovery, which create more advances in the methodology. And I think computer science is like that. So I think we will be advancing the core of our field at the same time that we tackle these societal challenges, and I think that's computer science. So I think there is an expanding center of the field. Please.
As a follow-up on that, I very much agree with you, but so one thing is that students from other domains want to learn about computer science because they realize how much these skills will help them. But how about helping computer science students realize the broader context in which they can apply their own skills, like integrating, not only providing modules for other students to take computing models, but also bringing in outside modules into the computer science education.
Yeah, this is another very challenging point. Okay, so what she's pointed out is that it's one thing for us to provide modules for students in other disciplines, but how do we cause computer science students to understand that there are a set of other fields out there with exciting challenges and opportunities that we should be coupled to. Lord knows I'm not an expert on undergraduate education. What we're doing at the graduate and postdoctoral level is our students, for example, in data science, and I'll use that as an example, have dual mentors. Okay, so all of the graduate students and all of the postdocs have a mentor in what I'm going to call an application field and a mentor in a methodology field, and a sort of vibrant seminar series that expose them to both of those. I think a simple thing we can all do is broaden our seminar series in our departments and our colloquium series so they incorporate a set of people who are advancing computer science in conjunction with tackling some of these societal challenges. We also have a surprising number of dual majors in our department, particularly in our arts and sciences program where it's easier to do it, and certainly encouraging that has benefit. You can imagine that introductory courses could have programming assignments that draw on applications from other fields, and this might be much more attractive to a diverse set of students than calculating polynomials or something like that. So I think there are lots of opportunities.
Daniela and then Beth, and then we'll close.
Okay, I have a question about your comment that all fields are becoming computing fields. So many departments, all other departments are beginning to hire computer scientists. So what does that mean about the identity of a computer science department at the university? And what would you say to your president about the importance of your department?
So Daniela has asked a challenging question that's a sort of sister question of Moshe's. It's all sorts of other academic departments are hiring computer scientists. So where does that leave us, and what would you say to your university president about the core of computer science? I should ask what you're saying to yours, who's, after all, a computer scientist. Yeah. Right. Again, I think it is challenging. One thing to do is to make sure that these other programs are hiring top computer scientists, and that's an area where you can help them. At MIT, this isn't a problem. At many of our universities, it probably is. Another thing is to sort of embrace these people as part of your research program. It seems to me that we have to argue that advances at the core of our field continue to be important, and there are all kinds of ways to demonstrate that importance, right? So tackling these societal challenges doesn't just rely on utilizing today's computer science in different ways. It involves creating tomorrow's computer science, and we have to keep doing that and making that case. Mark, you're in charge.
Ed, this is fantastic. Thank you so much. Foreshadowing a little bit of the conversations yet to come in the symposium around labor and automation and privacy and security. You have primarily mentioned areas where computer scientists are seen as part of the solution. What is our responsibility, and how do we engage where we're seen as a major part of the problem?
Right. So another challenging question from Beth Minot. It is, we've been talking about areas where computer science is seen as potentially part of the solution, or at least we see it as part of the solution. What about areas where it's part of the problem? For example, the nature of work. And this is obviously very serious. It's not just displacement through automation. It's things like the gig economy and offshoring, which we fundamentally enable. There are estimates that something like 37% of America's workforce today works gigs, which means job to job to job. And there was a U.S. senator a year ago, I've forgotten who it was now, who was quoted as saying, "This works great for them until suddenly it doesn't." Right? I don't have a satisfactory answer here. I think that personally, just to get political about this, what we all have to do is to work on restoring the social safety net that made it possible for people to have discontinuities in work and keep their families together. And in the past, first of all, change came much more slowly, right? There was a time in which 90-some% of Americans who were employed worked on the farm, and that was only 100 and some years ago. And now it's something like 2%. And that change occurred over a long enough period of time that those farm families and their descendants were able to re-educate and repurpose themselves to other employment. Now change happens very fast, and the social safety net on which they were able to rely has been dismantled. Things like the Affordable Care Act are a step in the right direction. So I don't think we have the solution except through the way we vote and influence our neighbors to vote. And I think we have to realize that all of us have been the incredible beneficiaries of life. And many people who are in less fortunate circumstances did not have the good fortune that we did, and we owe them something. That's my political conclusion.
One more.
One more. Just quick. So this is Muhammad from Arizona State University. When I first joined Arizona State as an assistant professor, that was a year and a half ago, a lot of people will just communicate from astronomy, from physics, professors from these kind of departments. And it always aggravates me. And then they tell me, I want you to build a program. I want a programmer to do that, this and that in the beginning. But then I realized that I believe we should embrace the fact that computer science, this has been our job for 50 years, and this is our identity. And we can get a lot of challenges out of just building computer programs or computer systems for these kind of domains to advance our domain. So in the beginning, it used to aggravate me, oh no, I'm not a programmer, I'm a scientist, or something but it's our field is an applied science. We're not here to come up with we're not mathematicians, we're not physicists, we're not any of that. I mean, we use all these tools, of course, but we need to embrace the fact that this is our identity. And we can get a lot of challenges out of this. That's just the common basis.
Right, so
Here's the summary of this.
So Mohammed's comment is that we are an applied science and engineering field. We are in computer science as opposed to in mathematics because we like solving problems. And we should embrace helping other people solve their problems. And we can take away interesting computer science challenges by engaging with other people's problems. And obviously I embrace that completely. I hope I captured it approximately right. And I think the one thing I'd say in universities is, again, talking about my data science experience, we've had just wonderful experiences with people in oceanography, in astronomy, in neuroscience, in sociology, who understand that we need to move our research forward while we help them move their research forward. The physicists have continued to not get that, but that's okay. My astronomy friends say, don't feel badly, they treat me the same way. So I think at your universities you will find people who understand that a true partnership moves your field forward and their field forward. And my colleague Magda Balazinska, who has been really joined at the hip with survey astronomers for the past half dozen years, feels that she spends maybe 30% of her time doing work that moves the astronomy forward, but not her computer science, 30% of her time doing things that move the computer science forward, but not the astronomy, but the remaining 40% is moving both together simultaneously. And because of the astronomy engagement, that work is so much more effective that she's way more than paid back the 30% she spends moving astronomy forward. It's a small price to pay for the benefit to her research program. And I think being open-minded in that way can move us all forward. Thank you very much.